Sorry, apologies for that. Thanks for telling me. Sometimes I forget. So yeah, router on a stick. Open that up.
Sorry, which folder is it in?
So it's in the CCNA materials, slides and labs, day 6, VLAN labs.
Thank you.
Only check it. Okay. Fancy it.
If you go in here, so CCNA material, slides and labs, day 6, VLAN labs, and this router on a stick. Let me know when everyone's
done.
Good stuff. So we got it there, or?
Yep.
Good.
Yeah, sorry,
Yeah.
Cool. All right, great. All right, so basically let's just have a look. Now there is so what I want to do, I want to go through the theory of it first, guys, okay? And we'll actually just talk about setting it up, right? So in order to do this, I want to just go back to actually, let me just take a screenshot of this here first. So what we're setting up here is we are going to have this example here. Okay. So we're going to have two VLANs, VLAN 4 and VLAN 2. Okay. Actually, let me just take a snippet and I'll show it into you in Paint. So VLAN 4, VLAN 2. Let's say VLAN 4 is a red VLAN. And this is 0/4, keep things nice and easy. And the subnet here, I'll go by the document, is 172.12.4.4. Okay, so the IP address of this PC is 172.12.4.4. The default gateway is 172.12.4.1. So this PC, remember what I was saying yesterday, is that your VLAN ID should match the third octet of the subnet. So our VLAN ID, which is VLAN 4, is matching the third octet of the subnet, which is 172.12.4.0. That's the network. Yeah. We have another PC here. Now this is just one PC. We're just keeping it simple for one PC. But these PCs are just one of, maybe you could have 20 PCs in VLAN 2 and 20 PCs in VLAN 4, all connected to this one switch. So 0/2, and this is VLAN 2. Let's say it's blue VLAN, blue for 2. VLAN 2. This PC is 172.12.2.2, and its default gateway is 172.12.2.1. Okay. Now, if we looked last week at static routing, let me just open up a static routing slide here, whenever it comes up. No. Here we go. Open Paint. Okay, we know this, right? So let's say we have this Dublin PC here. This Dublin PC is on the 192.168.1.0 network, yeah? Its IP address is 192.168.1.2. Its default gateway is where it connects into the local physical interface of the router. So in this PC's default gateway is 192.168.1.1, yeah? The PC in Cork its IP address is 192.168.3.2. Where it connects into the router is its default gateway. So its default gateway is 192.168.3.1. So typically a device's, a laptop default gateway is going to be the connecting interface of the router IP address. Okay, this laptop here ultimately connects back to this router interface, which is 3.1. Ergo, the laptop's default gateway is 192.168.3.1, right? But this is where we have a problem, is because we've got one physical interface on this router that has to act as two different default gateways. Because we got, with a switch, what you do is you divide a switch into two different VLANs, into two different networks, but you've only got one physical port, one cable coming from this switch here to this router. So how can you take one physical, how can one physical interface act as the default gateway for multiple networks? So this is 0/0. So the answer is what's known as sub-interfaces, okay? So a sub-interface is where you take a physical interface like 0/0 and you divide it into multiple different sort of virtual interfaces, and each of these sub-interfaces or smaller interfaces acts as a default gateway for each VLAN. Because if you think about it, that's what we did on the switch. On the switch, we took a virtual chainsaw and we divided the switch into different networks, VLAN 2, VLAN 4, and we associated ports with this. So we're taking this virtual chainsaw one step further, and we're taking it to divide this physical interface 0/0 into multiple different sub-interfaces. Okay, the command is very easy. You just go into 0/0, which is the physical interface, and dot. Okay, you say 0/0 dot, and then you specify, the router will say, what sub-interface number do you want? Now, if you're creating a sub-interface for VLAN 2, you can have any sub-interface number you want, but it just makes sense that you're going to call the sub-interface number to align with the VLAN ID. It doesn't have to. Okay, the first command, you say interface, interface 0/0.2, and that will create a sub-interface, and it will number the sub-interface 0/0.2. I'm putting a dot in there. Hope you can see that. Okay, now the next command is the important command, because the next command is actually where you tie this sub-interface with the VLAN ID. The command is encapsulation dot 1q space 2. Okay, so this is where you say, I want this sub-interface of 0/0.2 to be mapped for VLAN 2, to be the default gateway for all the devices associated with VLAN 2. Okay, again, I could have interface 0/0.215, okay, and I could call it number 215, and that will still be the VLAN sub-interface for VLAN 2. It doesn't make sense why you'd add 215. You just keep it simple. You'd say 0/0.2 and have it for the sub-interface for VLAN 2. Because the next command, encapsulation.1q, maps it to VLAN 2. Does that make sense? Okay.
Yep.
Once you do that, then you give it an IP address. You give this sub-interface an IP address, such as the way we normally do, and this IP address will be the default gateway for all the devices associated with VLAN 2. So you'll say IP space address space 172.12.2.1. The same thing with VLAN 4. interface 0/0 dot, what number? 4, just makes sense. Encapsulation dot 1Q space 4, and then your IP address would be the IP address of the default gateway, IP space ADD 172.12.4.1. Okay. Any questions on that, guys?
No.
Okay, so let's do this lab together. So open it up, ruler on a stick. So physically, so what I'm going to do is open it up. I'm going to do, we actually don't need the documentation. Where are we here? Make this a little bit smaller. See, one sec. Make this smaller. So too small. And let me get the PC here. Okay, so the devices are already IP'd. So 172.12.2.2, 172.12.2.1 is the default gateway. Excuse me, this guy up here, 172.12.4.4, default gateway 172.12.4.1. Okay, and the device on VLAN 2 connects into FA0/2. The device on VLAN 4 connects into FA0/4. Okay. Yeah, well, I can make that bigger. Okay. So we go into the switch. Go to CLI, create the VLANs. So enable, put big space T, create the two VLANs, VLAN space 2, name blue, give it a name, exit, interface FA0/2, switch port, mode, access, switch port, access, VLAN 2. Okay, so you do that for VLAN 2 and VLAN 4. Name VLAN 4 red VLAN. Okay, so going off that command, do the same thing for VLAN 2 and VLAN 4. Okay. Let me know when you're finished. It's not a race. Let me know when you're finished, guys.
Oh, good. That's fine.
Good stuff.
Yep.
Cool. Okay, so I'll do the F here. VLAN 2, name blue. So again, exit. VLAN 4, name it red. Interface FA0/4. Switch port mode access. Switch port access. VLAN 4. Exit. Exit. Okay, is anybody still doing it? Okay, so everyone's silent suggests everyone's done. Okay, so we'll move on. So you can verify this by doing show VLAN or show space VLAN. And now you'll see that 0/2, the physical port 0/2 is associated with VLAN 2. The physical port 0/4 is associated with VLAN 4. Okay, that's the way it should be. Okay. Now again, they're on two different VLANs, they're on two different layer 2 VLANs. They're going to be on two different layer 3 subnets. The next step we're going to do is we're going to go and configure the router. Okay, so we need to go into the router and create the sub interfaces. So I'm going to create the sub interface. If I go enable, show IP int brief. So we're physically connected into FA0/0, but you can see, we said this last week, all your physical ports on FA0/0 are offline, are administratively down. You need to bring it up. So the first thing you do before you create any sub interfaces is you need to manually bring up 0/0. So config space t int FA0/0 and no shutdown. Brings up. Okay, so that's the only change that you make on that physical port FA0/0. Every change that you make after that is going to be on these sub interfaces. So you exit, go back to global config mode, and then you create your sub interfaces. So what I'm going to do again is I'm going to create a sub interface for VLAN 2, and then I'm going to get you to create a sub interface for VLAN 2 and VLAN 4 using the same commands. Okay, so interface FA0/0.2. There you go. I've just created a sub interface and I'm calling it number FA0/0.2. And you see it changes config-sub if. Anything I type in here is going to affect the sub interface of FA0/0.2. See it? FA0/0.2 sub if. So I give this, first thing I do before I give it an IP address is I need to map this sub interface with VLAN 2. So the command is encapsulation, just have it, .1q space 2. Remember, .1q is the encapsulation type. It's the 802.1q. It's the IEEE standard for VLAN trunking. You're saying, I want this to use 802.1q VLAN trunking and to tag it with VLAN 2. And then you just give it an IP address in the same way that you give your default gateway an IP address, which is IP space address 172.12.2.1 255.255.255.0. You don't need to do a no shutdown because the parent interface is already up. Exit. Okay, so that's the command for VLAN 2 for this to create a sub interface on VLAN 2. Let me just actually, what I'll do is I'm just put into Notepad, and I get used to do the same for VLAN 2, but also do the same for VLAN 4. Okay, so 1 second, make this a bit bigger. Okay, you have to do the same for VLAN 4. The IP address is going to be for VLAN 4. 0/0.4 will be 172.12.4.1.
Before we make the sub interface, should we not rename it as a trunk
On the switch,
from the switch to the router?
yeah, we are going to do that. I wanted to. That's good. Good spot. I wanted to just to not do it and then to see what the problem was, why it wasn't
Oh,
working.
sorry.
Well, you're after ruining the whole fun here for me, Graham. But great spot.
All right.
Spot. Well done. Yeah. But so we will do that. I will set this up here first, and then we won't be able to ping because there'll be an issue with the trunk connection on the switch that I went over quickly. So yeah, but we do this first, and then we go back to the switch. Okay, guys, just put in the commands there.
Done.
Okay. Cheers.
Done.
Good stuff. Let me know when everyone's finished.
Done.
Good stuff. Okay. So is everyone finished?
Fine here.
Okay. Right. So let me just go into the switch. Oh, sorry, the router. I need to finish it off. So we've done encapsulation at 1Q. So I need to do the same thing then for sub interface FA0/0.4. So int FA0/0 dot, and if I do question mark, it says what sub interface number do you want to create? Any number at all. It just makes sense that you match it with the VLAN ID. Again, you don't have to, it just makes sense. Interface FA0/0.4, create a sub interface. This is where you actually logically make the matching. Encapsulation.1Q space 4. Okay, encapsulation.1Q space 4. Exit. Oh, sorry, I should have went back in there. interface FA 0/0.4. I give it an encapsulation of 1Q space 4, IP space address 172.12.4.1, 255.255.255.0. And end. Now, if I do a show IP int brief, you can see 0/0 is divided into my sub interfaces. Any changes you make going forward, you treat this physical interface, you don't treat it as a physical interface anymore. You've got two new sub interfaces, 0/0.2 and 0/0.4. Okay, 172.12.2.1 and 172.12.4.1. Okay.
Is there a limit on the number of?
No, no, because they're virtual. So
Yeah.
basically, it's no overhead on the router. You know, like because it's logical, you could create as many sub interfaces as you want. You definitely have more. You can, you know, like you can have more VLANs than number of ports on a switch, because it's logical. So your only limit is the number of physical ports that you can have on your switches. But you're not going to need, you know, you're not going to use 100 VLANs or 1,000 VLANs, you know, connected to one interface on the router. Now the thing about this here, right? This is an old legacy way of doing it. Now, most times nowadays, they wouldn't use a router and a switch. If you have a VLAN, so you'd have it all done on a switch by using a multi-layer switch. And I will talk about multi-layer switch and setting up multi-layer switch. We'll do a different lab on that. Okay. So go back to the router. If I do a show IP route, you see there's two routes. The router says now I've got two different networks. It treats these two as two different networks. One network, 172.12.2.0, is connected to 0/0.2. How did it match? How did it match that network to 0/0.2? Well, how do you tell a router about network? You tell a router about network when you assign an IP address to its relevant interface. So for me, the very act of assigning 172.12.2.1 to this interface 0/0.2 and 172.12.4.1 to 0/0.4 told the router that 172.12.2.1, well, that's the 172.12.2.0 network. It's hanging off 0/0.2. Okay, so that's, are we ready to go? Are we finished? We'll go back to the PC. Can this guy here ping this guy, 172.12.2.2? Let's go. Oh, Graham, yeah. Let's have a look. Ping space -t 172.12.2.2. And Graham gave it away earlier on when it was a great question. What about the trunk between the switch and the router? Remember, you set up a trunk link on a switch, but also on the switch end, you tell the switch that this connection is a trunk connection. So if I log on to the router here, so the reason why we're not pinging, and I keep that continuous ping running, if I log on to the switch, do enable, and do show interface trunk, nothing comes up. If I do show VLAN, our trunk link was meant to be connected to 0/1. But 0/1 is showing up as an access port. So we need to change interface 0/1 to be a trunk link. So config space T int FA 0/1 switch port mode trunk and press enter. See that going orange. Okay, so do that. Interface FA 0/1 switch port mode trunk. And we keep keep an eye on that when it goes green. See what happens. Okay, that's gone green. Let's check our PC, and there you can see it's replying. Respond.
All good.
All good, good stuff. Cool. So guys, how are we getting on with that? Are we all finished with that? Cool.
Good, yeah.
It's good. Good stuff. Okay, so I'm going to close that there. I want to just talk about. I'm going to open up a separate lab, a new package tracer lab. Okay, I want to talk about setting up trunk links and access ports, because it can be a little bit confusing. Okay, and it depends on the switch as well. It depends on the switch. So let me just show you. So I've got package tracer here. Okay, I'm going to get two switches. Connect them in 2960 to 2960. Okay, I'm going to connect standard 2960 to 2960, gig 0/1 to gig 0/1. Okay, so obviously I want these two connections to be a trunk link. So let me just put a note there. Gig 0/1 to gig 0/1. All right. Sorry. All right. So I'm going to go into this switch here. Switch A. 1 second. I just see this button here is really useful to fast forward time. So I'll go into this switch here, and I'll say enable, and I'll say show interface trunk. Okay. So the switches do not trunk automatically. You see that? So we connect the connections between the two switches. They don't show it. So it's a very, very useful command that if you set it up, that make sure you have to hard code them as trunking. So what I want to do here is we'll have a look here. We'll do show interface gig or to show interface gig 0/1 space switch port. So we're saying I want to show the configuration for 0/1 regarding the switch port. Okay. And you can see in here, so it says gig 0/1, it's enabled. It's auto, it's set to auto here. Okay. So auto means that it's set to auto negotiate with the other switch. Okay. It's set to auto negotiate. So basically what happens is when this is set to dynamic auto, if the other switch is set to dynamic auto, which is the default option, then both switches will not trunk with each other. Okay. If it's set, so the default option on this switch port here on gig for this switch is if I connect a link on gig 0/1, it will automatically, this dynamic auto will say, well, I will wait for the other switch to contact me to try and set up a trunk link. And if I don't hear anything from the other switch, well, then I'm going to go in as an access port. So dynamic auto is how it resolves to be a trunk or an access port. A static access means it's an access port. Okay. So your default option here is dynamic auto. Okay. Let me just do a screenshot of this again because it can be a bit confusing. Do a snippet. You have got different options for a switch port. Okay. One of the options is it's going to be a trunk. So if I go into gig 0/1 and I say switch port mode trunk, what will happen? That will trunk. Okay. So the plus sign, the blue sign is when it's going to be a trunk. If I go in and I say switch port mode access, what I'm doing is I'm saying to the switch, I want this port to be hard coded as an access port. Okay, that's straightforward enough. Switch port mode trunk is your hard coding it to a trunk link. Switch port mode access is your hard coding it as an access port. Yeah, there's two other options. There's dynamic auto, which basically waits for the other switch. And then you have dynamic desirable. And dynamic desirable desires to become a switch, or desires to become a trunk. Okay, so it's the last two that can be confusing. Does that make sense? Like if I go into gig switch A here and I say switch port mode trunk and gig 0/1, well then this connection is going to become a trunk link as far as switch A is concerned, because I'm basically saying I want gig 0/1 to become a trunk. I don't care what the other switch is doing. Okay. If I go into switch A and I say switch port mode access, you're saying I want this switch gig 0/1 on switch A to become an access port, and it'll become an access port. If the default option on the 2960s is this auto negotiation. I don't like using auto negotiation because the trunk link is the most important link, or one of the most important links in your network infrastructure. So you auto not use auto. Think of it that way, okay? So your default option, okay? So gig 0/1 on switch A is auto. And if you look at the description, basically switch A, gig 0/1 is auto. It means it's waiting for the other switch to contact it. So it's not going to do anything. It's sitting down there. So I'm not going to do anything. I'm going to wait for the other switch, right? But if gig 0/1 on switch B is auto as well, what's going to happen? Each switch is going to wait for the other switch to negotiate a trunk link. But they're not going to dynamically find out what they are. They're just going to sit there forever and ever and ever, and they will default, as we've seen it, to access ports. Like we've seen it there. Dynamic auto basically means I'm just sitting here. I'm not doing anything. And because the other switch port is also doing the same thing, it's also set to dynamic auto, then the result of those two ports being dynamic auto means we're going to have an access port. Okay. Now, dynamic desirable is a bit more dynamic desirable will send a message. Okay, so if let's say we have auto here on gig 0/1 and we configure gig 0/1 on switch B to be desirable. Well, look at the term desirable. Desirable means that switch B will initiate a trunking connection. It's called a DTP. It'll send a dynamic trunking protocol. It'll send a message, DTP message, saying, would you like to trunk? Let's trunk, okay? Because I desire to become a trunk link with you. And A says, oh, I thought you would never ask. I'm set to auto. So if you're set to desirable and I'm set to auto, well then let's dance. Let's become a trunk link.
Why wouldn't you just trunk them and take that option out of the equation?
You do. You do. I don't like the way it's set up. I don't like the way it's set up because it just confuses things. So you basically go in to the switch and, well, let me show you this. So one end is auto, okay? This is dynamic. And the other end is dynamic auto. But I'm going to change this to dynamic desirable. Okay, so I'm going to go in. So if I do this, enable, show interface gig 0/1 space switch port, and you can see the same thing at the moment. The default option is dynamic auto, and this is an access port. Okay, so I do show int trunk. There's no trunk link. So I go in config space t int gig 0/1 switch port mode, and you can see in here. So your access we talked about is you're basically saying this is an access port. Your trunk link is saying this is a trunk port unconditionally. I don't care. There's no conditions attached. This is where I don't like this dynamic, because there's conditions attached. There should never be conditions attached to such an important connection like a trunk link. So switch port mode, dynamic, and then you got your options. Dynamic auto or dynamic desirable. Like I said, your default option is auto, but I want to change this to desirable. Change that to the dynamic desirable, both connections. Now what happens? Now this switch B here will send a message across to the other switch. It'll say, let's dance, okay? And because now one switch is making the connection, it is trying to initiate a connection. fast forward this, and go back in here, exit, and do show interface trunk, and now gig 0/1 is desirable, and we're trunking 802.1q. Okay, what about this one over here on switch A? Enable show interface trunk. This is still auto, but it's still trunking. The reason why it's trunking is because switch B initiated the trunk connection. Does that make things a little bit clearer?
Yep.
Yeah.
So basically, if one switch is set to desirable and the others are auto, then it'll
Trunk.
trunk.
Yes. If two of the switches are set to auto, what happens?
They won't talk.
They won't trunk. They'll stay in access port.
If you go in and look at on the V, if you go in and look at the VLANs, will those access points still? Will those ports still be visible?
Oh yeah, very good question. So show VLAN. Will you tell me?
They should be, because they're
trunk links. Gig
they're
0/1 should not be here. It's gone. Very important, very important. The show VLAN command only shows you your access ports. It doesn't show you your trunk links. So when you do a show, like that could be an exam. It could give you the output of this and say, what port is your trunk link? Is it FA 0/1? Is it gig 0/1? Or is it gig 0/2? And you can fairly make an assumption here that the answer is going to be gig 0/1 because it's not there. That's the type of questions you're going to expect. But the best way to do this is by doing this on packet tracer, setting it up, changing it to switchboard mode, trunk, switchboard mode access. There's one more thing I want to talk about quickly, is throw a spanner in the works completely here, is that with other ports, with other switches, I think we talked about this yesterday, these guys, 3650. Oh, they're the wrong ones. So let me just, they're the other ones. These are your multi-layer switches, okay? Excuse me. Gig 0/1 to gig 0/1. Fast forward time. When they hear, let's say this is switch A. So enable, no, enable. Oh God, crap. Control Shift 6 next. Okay. So enable, config space T, host name SWA, switch A. This is A, okay. And over here, now enable config space T, host name SWB, exit. Okay, so do show interface trunk. Okay, no trunk link. Exit, show interface trunk. Okay, so again, show interface gig 0/1 switch port, dynamic auto. Okay, same mode, right? But watch what happens if I try and set this up as a trunk link. Int gig 0/1 switch port mode trunk. An interface whose trunk encapsulated auto cannot be configured to trunk link. So we need to take it off. Okay. So the command is switch port trunk encapsulation.1q. Press enter. And then you say switch port mode trunk. Okay. So on the multi-layer switches, it's not a case of just going in and saying switch port mode trunk, you're going to get this message. So you have to do this. I want this switch to become a trunk link and use the encapsulation.1q and then hard code it as a trunk link. Honestly, it bugs me. You shouldn't have to do that, but that's just the way it is. So this end here is a trunk link. So if I do show interface trunk, because I've hard coded it. If this is a trunk link and the other switch is set to auto, what's going to happen to this switch over here? Will it be an access port or a trunk port?
Access.
Trunk.
It'll be a trunk, yeah. Because when you set this up as a trunk link, it will send across a message to say, would you like the trunk? And it will. So this one here, if we go in, show interface trunk, it's still in auto mode, but now it's trunking. The only reason why it won't trunk is if you set it as an access port or if both are set to auto.
But again, it would be good practice to make both ports trunks.
Absolutely, 100%. So the command to make this config space t int gig 0/1 switch port mode trunk. Will this work? No. Switch port encapsulation switch port trunk encapsulation .1q switch port mode trunk. Okay, which leads me on to homework for VLANs. Let me just get me bits and bobs. Where are we? Day 6. Same troubleshooting lab. Again, guys, if you can just take a few minutes to do this. The solution is there on the Microsoft. So I have the actual packet tracer lab, and the solution is there on the PDF, right? But try and just do it first, okay? So basically, it's a similar network to the one we did. You got VLAN 2, which is the PC 192.168.2.0 subnet. You got the IP addresses. You got VLAN 3, which is the server VLAN 192.168.3.0. The settings you need to go, the diagram is correct here. This stuff here is correct. The information on the router and the switches are not. So basically, you have to go off the diagram and fix it. Okay. So when finished, so you don't change the diagram to suit your configuration, you change the configuration to suit the diagram. Okay. So again, it's easier to configure a network from scratch than to troubleshoot someone else's network. Now, when you do it, and if you're stuck, the solution is there in a PDF document. Try not to look at it. Try and do it. You know, try and attempt it from the get-go. Okay. Honestly, it's really you really learn a lot more when you're actually troubleshooting. All right, guys. Is that okay?
Yeah. Cheers.
Cheers.
Yeah. All right. Well, have a good weekend. I think Liverpool are winning. Any Liverpool
3-0.
fans out there?
3-0. Yeah.
Yeah. Salah's on it.
Hat-trick.
I have him triple captain on my fantasy football, so I'm getting about 60-70 points off him. So that'll be good to go. Anyway, right. So guys, yeah, have a good weekend, and I'll see you on Tuesday. Yeah.
Cheers. Thanks.
Take it easy.
Thanks, guys.
Thanks.
All right.
Cheers, Lee.
Yep.
Thank you.
Thank you. Bye bye.